Okay, this is the second session on Genesis 1 through 11. And in this section, the first session, we dealt basically with the text of Scripture and the description of the creation in Genesis 1 and 11. This second session that we're going to do on Genesis 1 and 2 has to do with the scientific aspects of this creation. This one we're titling, it's also Genesis 1 and 2, and this has to do with the law of creation. This is the second part. The creation in Genesis 1 and 2 is actually the creation of our first law of science, and we're going to go into that. This is very significant because as a student at MIT, I came out of a process of the panic that was created by the Russians putting Sputnik in, and I'll mention this again in our fourth session. The government, when they realized they could put up satellites, they could also send intercontinental ballistics and drop on us, and so there was a general panic and everyone started building bomb shelters. They were setting up public buildings for bomb shelters, the radiation detection systems, and also there was a strong push in academics to get our educational system very strong in mathematics and science. And so they tested almost every student in junior high and high school. And if you scored well on there, you were invited to come to government freely to government science camps taught by full professors. And the push was to push this up. I was one of the fortunate ones. I passed high on the tests and was invited to these camps, went to these camps, and was trained in the area of science and math. And it was really probably that training that I got that allowed me to qualify high on the SATs and to get into MIT as a student. And when I went there, I knew this, but the way the math and science is taught today, as it was at that time, is science is disassociated. It's like a big smorgasbord. And you're taught mechanics, you're taught electromagnetism, you're taught optics, you're taught wave theories, you're taught these different aspects of science and of physics, but they're non-unified. And so I was in a very good living group, and we had the files of previous exams. And so I was going over these exams, preparing myself for the exams that we were going to take, because I knew physics was at the heart of science, because as most of you know, biology is just a form of chemistry. There's no nuclear changes, and there's a lot of chemistry that's not related to biology, even inorganic chemistry, and even some biochem that is not related to life systems. So, and chemistry is just the exchange of electrons. There's no nuclear changes. Physics, however, is biology is a form of subdivision of chemistry. Chemistry is a subdivision of physics, because physics also includes nuclear reactions as well as electron exchanges, the outer electrons. It changes the nucleus. And so I knew physics was at the heart of this, and so I was working very hard on these physics exams, and I still could only get mediocre grades. I was a C+ student. Of course, all these other students that I was going to school with were the top in the United States and probably in the world on standardized tests. We were better than Harvard or anyone else at that time in the math and sciences. Most of the guys, I'd say a third of them would probably never marry. They're true geeks. It was a term that we used at that time even, or tech tools, it was another term that they used. And what are you going to talk about on a date, you know? Einstein's theory of relativity or something, you know, that's not a very good topic on a date. But anyway, so I was striving for this, but I still couldn't get over it. The problems, they came up with problems I'd never seen before. And finally, this one fellow who was kind of my pledge father took me aside and he says, "Dave, I understand you're having trouble with this physics. Could you explain to me, let me see how you're doing?" And he'd slap some of these problems down. I started to write my little formulas and everything because I knew this thing like a rat running through a maze, you know. And so I'd start through the thing, and he says, "I know what your problem is." I'd start to write my little formulas down. And he said, "I know what your problem is." He says, "The whole material realm that we're dealing with is only made out of math and science. Matter and energy. And everything is involved in that. And there's only 2 laws that are involved in that. And that's what we're going to study today is the first of these laws. And he took me from a C+ student to an A+ student, physics. He says, these professors from MIT are paid the big bucks to come up with problems you've never seen just using these 2 laws. And we had a couple of professors, you could sit in their classes, they could work any problem that was thrown down in front of them just from the hip. I was stunned by it. And I knew that there was some trick to it. I said, I knew there's some trick. You guys were making straight A's here, and the rest of us were struggling. So we're going to go into this. But I didn't know at that time, and for a long time, what the origin of these 2 laws were, that we get all of our laws of science from. And that's what we're going to go to. And these 2 laws come out of Genesis 1 through 3. That's what's so absurd about this. They trash them out. But that's why our science is trashed out. It takes a genius to get through science and math, when really it's very simple. If you understood these laws, you can solve almost any problem you'll face. So this, Genesis 1 and 2, has to do with the creation, the beginning of this first law. The end of God's creating, bara, out of nothing and also fashioning things that he created out of nothing, after 6 days marks the beginning of the first law of conservation of matter and energy. And the logic of this will be stunning to you. It's the basis of most of our laws of science. Most of our laws of science are conservation laws. I don't care if it's ideal gas laws, gravitational, electromagnetic fields, wave propagation, everything comes from this law. In every reaction, there's a conservation of matter and energy before and after you have the same amount. So, at the beginning, the 6th day of creation, it's all finished. What you got's what you got. And from that time on, it becomes the basis of almost all of our, what we call ideal laws of science, which are conservation laws. We don't live in an ideal world, but they define the basic laws that if we had a perfect universe, would be still in force. Since the end of creation, not 1 gram of matter or 1 joule of energy, as I've said before, has been created or destroyed. The universe has the same quantity of matter and energy in the universe today as it had at the end of the 6th day of creation, except in the case of miracles, like we saw in John, baking enough food out of 5 loaves of bread and 2 fishes to feed 5,000. You're generating matter and energy. To make it disappear, like the calming of the sea, saying to this tempestuous sea, peace, be still. It's not only stopping the wind, it ate up all the energy. Those are violations of this law. And except for miracles, this law is the law of the universe. This conservation law is also the basis of our mathematics, conservation of quantity. All mathematics is keeping track of the quantities. What's 1 plus 1 is 2, okay? What's multiplication? 2 times 3 or 3 times 2? It's addition of 2 sets of 3 or 3 sets of 2. If you go to exponentials, what are you doing? It's just a fancy way of doing multiplication. What's integral calculus? You're just adding incrementally. And once you understand that, and what's plane geometry? It's in 2 dimensions. It only has to do with the right triangle and Pythagoras' theorem, which is a conservation law. Trig is in 3 dimensions. Same thing, right triangles and Pythagoras' theorem. And you can solve everything. It's stunning. Most of everything we have, that's why math is so good for physics. Because it's just a virtual way of keeping track of the physical world. When we sent the men to the moon in the Apollo project, those equations, do you know what they were? They call them Hamiltonian equations. They're just addition equations based on keeping track of energy and matter. And they can't get back to the moon, I think, because these things weren't written down when I was a student. They're not put in textbooks. And the people don't know how to write those equations and keep track of the things. The rockets, it was just Hamiltonian equations, just keeping track of stuff. Conservation of matter and energy. A little sophisticated solving of the problems. You could set up the equations, you couldn't always solve them because they were differential equations are very difficult to solve. You can solve them point by point. But coming back to it, it's all this first law is based on this. Let's look at what this first law of science is. It's conservation of matter and energy states that the total amount of matter and energy in each interaction and also in the whole universe is conserved. You have the same quantity before and the same quantity after. All of our ideal laws of science, as I've said, are conservation laws derived from this first law of conservation of matter and energy. Now, if you plot it, let's plot it here. Time in this direction, you go in this direction, it's the total amount of matter and energy. Here we are at the present time, and what it is, it's a straight line. 1,000 years ago, have the same quantity of total matter and energy that we have today, and 1,000 years from now, it'll be the same amount. It's a flat line. Pretty simple law, really. Why is this first law true? It's because in the beginning, God created the heavens and the earth. And at the end of the sixth day, he was finished creating matter and energy. It's done. Then God blessed the seventh day and sanctified it because in it he rested from all of his works which God had created and made. It's all finished. He's rested. Not creating from that point of view, except for in the case of miracles that he does. That's not the norm, though. Miracles are not the norm.